All right, question of problem simplifying sometimes. Can you do an example? Least common denominator, simplifying each side. Least common denominator and simplifying each side. Are you talking about going back to the chat? Miss Ballin, are you talking about having a fraction in an equation? As I think it's 1.2. Okay, okay, I'll do one of those. And if the one I choose isn't what you're talking about, then just let me know. But that's why I'm saying, like, guys, if you have a question or a specific type of problem, it's easier if you actually, say, okay, my math lab out of 1.1, number 3. Like if you can do that, I can go into my math lab and see the type of problem you're talking about and do one like that. So moving forward, that's the easiest way for us to address, any type of problems you may have, whatever assignments, whatever problems or problems or exercises you see, whether it be in my math lab, the book or whatever. If you can pinpoint it by, like I was saying, my math lab homework 1.3, number 5, then I can go to that and bring it up. Okay, 2x squared minus 3x minus 1. Okay, I'll do this word problem and then I'll come back to that problem. All right, so dealer's cost. I don't think well, matter of fact, I can go back and look. I don't think I did one like this last class. Give me 1 second, guys. Trying not to repeat. Okay, so we did an interest, selling price, refrigerator. Okay, those are only 2. Okay. All right, so after a 20% reduction, you purchase a TV for $336. What is the TV's price before the reduction? So this is similar to one of the problems we've done before. In this problem, we'll have, you think about the reduction, the price reduction relationship. You're going to have an original price. You're going to subtract the price reduction. And that's going to be equal to the sales price or purchase price. So the price before the reduction is our original price. That's what we want to find. We can call that X. The sale price or the purchase price is $336. So the price reduction, it was after a 20% reduction. So first you recognize that's going to be 0.20 as a decimal. And you want to take 20% of your original price. That's what you're going to subtract. So that would be 0.2 times X. Remember, of is multiplication in mathematics. So 20% of the original price is what you're going to subtract from your original price in order to get the sales price. So that's what we have here. Questions on the setup before we go any further? All right. So When you look at this, we have x minus 0.2x equal to 336. Don't forget there's a 1 sitting out in front of that x. So you actually have 1 minus 0.2, so it's going to be 0.8x. Now divide both sides by 0.8. X is equal to, what's that, 4, 26, that's 3. I think I'm missing a digit. Hold on. Let's see if I'm right. I know I was missing something on mine. 420. All right. Questions on that one before we look at another one? So I believe for the most part, with most of you, the challenge is to set up the problem. You know, setting up your variables, setting up your equation. So you know, it just takes a little practice. All right, so you are choosing between two health clubs. Club A offers membership for a fee of $40 plus a monthly fee of $25. Club B offers membership for a fee of $15 plus monthly fee of $30. After how many months will the total cost at each health club be the same? What will that total cost be? So a few things we need to establish. Our variable, it says after how many months. I'll probably go a little brighter than that. So go back to the purple. After how many months? So X months of membership. All right. Then we need an algebraic representation for Club A. Club A is $40 plus a monthly fee of $25. So Club A is 40 plus 25x. Excuse me. And then Club B is $15 plus a monthly fee of $30. All right. Appreciate that. Thanks. So that's $15 plus a monthly fee of $30. And so that monthly fee is 25 times that. So after 1 month, $25. After 2 months, you pay $50. After 3 months, you pay $30, and so on. And that, I mean, not 30, 75, excuse me. And that's plus that 40. All right. So after how many months will the total cost, what happened to my T? Total cost at each health club be the same. So same is the keyword here. So we're going to set both club expressions equal to each other. Any questions? All right. So we can solve that. We have x in 2 different spots on different sides of our equation. So your goal should be to get all of your terms with x on one side, all of your terms without x to the other. So subtracting 25x on that left, leaving me with 40. On the right, 15 plus 5x. And we want to subtract 15 from both sides. 25 is equal to 5x. So divide both sides by 5. X is equal to 5. So this says after 5 months, the total amount paid would be the same. Because remember, initially what ends up happening is that you have an initial payment for Club A, it's $40. You pay $25 a month. The initial payment for Club B is $15, but you're paying $5 more per month, $30 a month. So at some point, the fact that you're paying $30 a month is going to pass the fact that you paid $25 a month. So they're saying the 5 months, that $15 will not matter, and you're going to catch, Club B will catch Club A, and then next thing you know, you will be paying more for Club B than you would have for Club A, even though Club A asked for $40 initially and Club B asked for $15 initially. So that is the first question. The second question says, what will that cost be? So you would just take one of the expressions. It doesn't matter which one. If you plug in 5 into either one of those, it will give you the same result. So why is this not erasing? And I'll do both of them just so you can see, but you don't have to do but one if you did it correctly. So we're plugging in a 5. So 5 times 25 is 125. And that's 165. This is 15. 30 times 5 is 150. 150 plus 15 is 165. So like I said, it didn't matter which one you decided to use. 165 was the answer that we needed because we wanted to know what would that price be in 5 months. All right. Questions. Someone asked about this type of problem next, and I haven't forgotten your question in the chat. We're trying to address these in order. I don't think we did this problem last class. So, come on. There we go. So, Miss Ballin, is this the type of problem you were talking about? When I was asking about fractions, simplifying each side. Yes, no, so, wait, it's fine, but we can go ahead and do this one. So, find your LCD, smallest number that both, well, that 6, 8, and 4 can divide into evenly. That would be 24. And like I said, the main thing you want to do is find a number that both, I keep saying both, but we have 3 denominators here. You want to find a number that 6, 8, and 4 can divide into evenly. You also, you could have used 48. Let's say if you saw 48, 6, 8, and 4 can divide into 48. So it doesn't matter what the number is necessarily, as long as 6, 8, and 4 can divide into it evenly. Also, when we say least common denominator, we're trying to find the smallest number that they can divide into evenly. So we will take that and multiply it to each numerator. Okay. Hold on, I got kicked out. Everybody's still there, right? Somebody get thumbs up or yes. Let me go back. Okay. I don't know what happened. I just got kicked out. So let's go back to, let me see, I'm still recording. Okay, good. All right. So yeah, I don't know what that was. Okay, so 24, we multiplied that to each numerator. Now the 6 can go into the 24, leave you with 4. 8 divides into 24 leaves you with 3. 4 divides into 24 leaves you with 6. So that's 4 times x plus 3. 3 times 3. 6 times x minus 5. All right, distribute. 4x plus 12 is 9. 6x minus 30. I can combine my like terms on the left. 4x plus 12, 6x, and then we have negative 30 and a positive 9, which is negative 21. Now I want to get each term with x on one side, each term without x to the other. So add 21. Subtract 4x. Make sure. All right. Divide by 2. X is equal to 33 over 2. All right, questions before I do the next one. All right, so going to the chat. So we got 2x squared minus 3x minus 1. Miss Lassiter, do you want me to solve this with a particular method? Are we using the quadratic formula, completing the square, factoring? How you want us to do that? All right. So if it just says solve, you can do what you want. But certain ones may ask for a certain style or certain method, depending on the assignment. What I would do, I probably would try to factor it. That's normally my go-to. But if you want to use the quadratic formula, we can, in which, since we have one side set equal to 0, let me see. I did factor. So did your factor not turn out right? Is what you're saying? Let's go here. Let's see if it is factorable.
Okay, can you hear me?
Yeah.
Okay, so I don't know where I went wrong. Sometimes I be factoring and I don't know somewhere I don't know. Because all I know is that if you go to the store, you can swipe that ATM card and none of this matters. So I think that gets in my head, and then that's how I get the wrong answer. But you do teach me any way you want to, and we're gonna try to figure it out.
All right. All right. So was that a child in the background? Because I understand maybe that's why you were chatting.
Yeah, I have my children. They're supposed to be napping, but as you know, that ain't working out right now because I'm in
Nah.
class.
So now I understand. It's all good though. Trust me, if I didn't have mine sent upstairs, locked up in the dungeon, then they'll be down here terrorizing as well. So here, if you try to factor this, isn't factorable. So we can do completing the square or quadratic formula. Probably the easiest one would be quadratic formula. So whenever you have, if you're going to use the quadratic formula, make sure you have one side set equal to 0. And then from there, you can establish what values are A, B, and C. If you had a set equal to 0, what's sitting in front of x squared is A. So that would be 2. B would be -3, and C would be -1. Of course, make sure you don't lose those negatives. From there, quadratic formula is -b squared. Nope, not -b squared, -b plus or minus square root of b squared minus 4ac all over 2a. So that's -3, so don't lose a negative there either. -3 squared minus 4 times 2 times -1. And then 2 times 2. Any problems or concerns with the substitution? So always remember, if your equation is factorable, and even if it's not factorable, you still can use a quadratic formula. So let's say if it was factorable, but you didn't see the factorization, quadratic formula will work regardless as to what's going on. So this will always work. So negative to negative turns positive. So that's a positive 3 plus or minus 3 squared is 9. And we have -4 times 2, which is -8, times -1, which is a plus 8 over 4. 9 plus 8 is 17. So 3 plus or minus square root of 17 over 4. And that's it. Can't do anything else with that.
All right, so that's how I put it in my math lab, but they don't want it like that. So I guess I gotta just just write both problems.
Yeah, so when you say that, are you saying this?
And then, yeah, and then the negative one.
Yeah, they didn't I don't believe my math lab give you the option to put plus or minus. So you do have to separate them. And
Okay,
probably separate them with a comma when you write them. Yep.
okay.
All right.
Thank you.
Not a problem. All right, y'all. What else we got? Somebody else have anything they want to see done, a type of problem? Feel free to suggest anything. Excuse me. Let's try this one out. Let's see. All right. So this type of problem is in 1.6. We have x minus 4 raised to the 2/3 power equal to 16. So to get that 2/3 power off of x minus 4, you have to raise it to the 3/2 power. And of course, whatever you do to one side, you have to do to the other. So that 2/3 as an exponent and 3/2 as an exponent will cancel. Power to a power, you multiply your exponents. And whenever you multiply reciprocals, the answer or the result is 1. So that's x minus 4. Here, if you're raising both sides to the 3/2 power, don't forget that the bottom is your root or your radical. So that's the square root. So that means we have to implement plus or minus. Don't forget, whenever you take the square root of both sides, you have to do plus or minus. And remember, we talked about that. If it's even, if that denominator is even, this is the result. You have to do that plus or minus. So even if that was 3/4, you have to do plus or minus because it's the same type of effect that it has on a number. All right, so now we're looking to take the square root of 16 and cube it. It doesn't matter which order you do it in. You could cube 16 and then take the square root of that. I just did it in the more familiar way because I'm not picking up a calculator. But either way, you'll still get the same result. Square root of 16 is 4. 4 cubed is 64. So now if I did it the other way and cubed 16, then that will give me a large number that I'm not familiar with. But if I were to take the square root of that, then that would have gave you the 64. So either way, you get the same result. Just maybe dealing with larger numbers or maybe unfamiliar numbers. From here, you add 4 to both sides. X is equal to 4 plus or minus 64. Then, of course, you do both. So those will be your two answers. All right, let's look at this one. We have x to the 2/3 minus 1/3, or x to the 1/3 minus 6 equal to 0. All right, so here we have a quadratic scenario. And so what I mean by that is that we have, well, I'll just rewrite it first. X to the 1/3 squared minus x to the 1/3 minus 6 equal to 0. So whenever you have this term being squared in the first term, that's considered a quadratic scenario. You can rewrite it as a quadratic equation and then solve it and bring your terms back in afterwards. So what I can do is let u be equal to x to the 1/3. Now my equation is u squared minus u minus 6 equal to 0. And so you do stuff like that just to make things a little simpler as you go about trying to solve. And then afterwards, you bring your x to the 1/3 back and then finish off the problem. So I can factor this. My sign should be different because I have a negative in the back. And I want my factors of 6. In other words, numbers that multiply to give us 6, but then have to subtract from each other to give us -1. That's a -1 sitting in front of that u. So that would be -3 and a +2. -3 times +2 is -6. Then -3 plus 2 is -1. Set each piece equal to 0 and solve for u. Here u is equal to -2, u is equal to +3. Subtracting 2 from both sides, then adding 3 to both sides. Any questions? All right, so we're not finished because we can't forget that u is equal to x to the 1/3. X to the 1/3 is equal to -2. X to the 1/3 is equal to 3. Now to get rid of that 1/3, we have to cube both sides. One-third and 3 for your exponent will cancel, leaving you with x. -2 cubed is -8. Once again, the cube and the 1/3 and the cube will cancel. X is equal to 27. Questions? Any questions? All right, so let's look at this one. Square root of x plus 8 minus square root of x minus 4 equals 2. First thing you want to do is isolate a radical, because your goal should be at this point, or at this moment, to get those radicals off of your x's so that you'll have access to them. Don't have that at this moment, so we want to isolate one of them. Easiest one to do is to isolate that first one. So we'll add the square root of x minus 4 to both sides. Cancels out on the left, leaving you with just the square root of x plus 8. And on the right, square root 2 plus the square root of x minus 4. Now I want to square both sides. Do that so that the square and square root will cancel on the left, leaving us with just x plus 8. Then on the right, you cannot square 2 and square the square root of x minus 4. That's a binomial distribution. If I do it like this. So it may run out of room, so I'll bring that down. So 2 times 2 is 4. 2 times the square root of x minus 4 is 2. Square root of x minus 4. Square root of x minus 4 times 2 is 2. Square root of x minus 4. And then square root of x minus 4 times the square root of x minus 4 is the square root of x minus 4 squared. All right, so that's 4 here. Combine your like terms. So that's 4 square root of x minus 4. So all you do is add the 2's in front. And then back here, the square and the square root will cancel, leaving you with just x minus 4. All right, so combining our like terms, 4 and negative 4 will cancel. So we have 4 square root of x minus 4 plus x. So we go back to our problem. X plus 8 is on the left. 4 square root of x minus 4 plus x is on the right. So before we go any further, make sure we're okay. All right, somebody in the chat. We're not okay? All right, talk to me.
I have a question. So when you distribute, so you did 2 times 2, then you did 2 times the square root of x minus 4, right? And then you did the same thing, which is x, the square root of x minus 4 times 2. But then with the square root of x minus 4 times the square root of x minus 4, does that just get rid of the square root and just x minus 4?
Well, that's what happened right here. That was the result. So whenever you're multiplying square roots and radicals and all the good stuff like that, let's say if I had the square root of 3 times the square root of 2, as long as the indexes are the same, as long as I both have square roots, I multiply what's under the radicals, and that'll be the square root of 6. So that's just 3 times 2. So when I look at the multiplication that you're talking about, I had the square root of x minus 4 times the square root of x minus 4. So if I'm multiplying what's under the radical, that's x minus 4 times x minus 4. And I'm just writing it all out. X minus 4 times x minus 4 is x minus 4 squared, unless you decide to expand it. And that square and that square root cancels, leaving you with just x minus 4. So
Okay.
that's what happened.
That makes sense. Thank you.
Okay. Not a problem. All right. Okay. See chat. My math lab, when the answer is negative fraction, do we need to put the minus sign in the numerator? It shouldn't matter. Someone was asking that, let's say, and this, let me know if I'm incorrect. If you have, let's say, negative 5/4 as your answer, this should be the same thing. It shouldn't matter. So, yep. Whether you put it in the numerator or out front, it should be okay. Because I read your email, it says, read the email and it says the minus sign, but I didn't put them. Check your answers because, and hold on, let me make sure I'm looking at the right name. Yeah, check your answers because when I looked at WeberSign, that's another class. My math lab, it said that your answer was whatever. Let's say if it's 33/2, it said that your answer was positive 33/2, and they were looking for negative 33/2. And then in the other one, you had like 22, and I don't remember what the numbers were, and it was negative, but they were looking for negative 22/1 and positive. So you had your negative sign switch here. In the bottom one, you had your negative sign switch here, and then this one you didn't put the negative when they were looking for. So that's what I saw. So check that out again and see what you see, and then let me know.
So we can't get extra credit for having close to the ball field?
Close to the ball field? You you asking me, can you score just by stepping near the ball field? You got to get in there and hit the ball and hit the bat and all that. What you doing?
I came on the plate. That's all I'm asking.
But yeah. So if you're close, that's going back to what she was saying because she was asking me about her test, and I gave her partial credit. I gave her 0.8 out of the 1. Because I do understand mistakes happen, and just like she said, she put the negative, but for some reason it didn't record that she put the negative. Unless it was the other way around. Either way, I know it was a negative that either was supposed to be there or not supposed to be there. And the answer and my math lab was looking for the other one. So if you put a negative when you weren't supposed to, or you didn't put a negative when you were supposed to, I can give you partial. I don't mind doing that, but I need you guys to go in there and look at your answers. So like I said, I'm not going through everybody's tests looking for points to add, Coleman tests to try to figure out where I can add points. But if you go through your test, you scan your test, and you see that there may be partial credit there or something, what I would need you to do is say, Mr. Chucker, on test 1, number 23, that's exactly what she did. Test 1, number 23, could you take a look at it? I feel like I should have got this right, or, just take a look at it, something like that, and everything. The score we receive on our test in my math lab is not the real score. No, your test is your real score. So now, remember your homeworks. I said, I'm still on eraser. Come on. Okay, 75 to 84.9. I'll give you 90%, and then 85 to 100. I'll give you 100%. But that's just for your homework. Your test, your score is what your score is. So if you score 75 on your test, then you got a 75 on that test. All right. Questions before we finish off this problem? So we still haven't finished the problem yet. So let's see. So we're right here. It would be neat if I could copy this. Pretty sure you can't. That's something, but it won't let me. Okay, it's all good. X plus 8. 4 squared minus 4 plus X. I think that's what it is. Yep. All right, so this is what we have. Now we want to isolate that radical. So we will, because we still have a radical involved, we want to get rid of the radical completely. Recognize that when we subtract X from both sides, it actually cancels out on both sides, leaving me with 8 on the left, 4 square root of X minus 4 on the right. Now, at this moment, we could divide by 4 and make our numbers smaller. But what I want to do is go ahead and square, because I want to emphasize something real quick to make sure that we don't make this mistake. So I'm going to square both sides because I want to get rid of this square root. So when I square this right side, this square root and the 4 sitting on the outside has to be affected by the square. And that's the part I wanted to emphasize. So I have 8 squared, which is 64. And let me do this. 4 squared is 16. And that square root is going to cancel out with the square, leaving you with just 16 minus 4. I mean, X minus 4, excuse me. All right. Questions? All right. See a hand. Do you have a few minutes class so I can share my screen with you? Because it says, okay, yep, that's fine. All right. And making sure everybody's, yep, no problem. So let's go ahead and distribute. So that's 64 equal to 16x minus 64. Then add 64. That's 128 equal to 16x. All right. And then divide by 16. Try to stay consistent with my red. Divide by 16. X is equal to 8. All right, questions. And of course, you would go back and check. Let me see what the original problem is. 8, 16, 4, 4, 2. Yep, so that will work. So, yep. All right. We got 6 minutes left. I'll do one more since you guys love math so much. I know y'all wanted one more. All right. Here, now try to do this. Get it out of there. No one said that foolishness. So here, just in case you were to see one like this, square root of 3 square root of plus, square root of x plus 1 equal to the square root of 3x, and that's minus 5, not plus 5. 3x minus 5. So I want to get rid of my radicals. So the first thing I can do is square both sides. So this square and this square will cancel. Square and square root, and this square root will cancel. Leave me with 3 square root of x plus 1 equal to 3x minus 5. All right, so I have to square both sides again because I still have a radical involved. This square has to go to both pieces. That 3 and the square root, it cancels out the square root, but it will give us 9 times what was under the radical. So it's x plus 1. And here, 3x minus 5 times 3x minus 5, 9x squared minus 15x plus 25. Combine your like terms, that's 9x squared minus 30x plus 25. I'll go ahead and distribute this. 9x plus 9, 9x squared minus 30x plus 25. So that's our new equation. Need to set one side equal to 0. So we'll subtract 9x and 9 from both sides. Minus 39x plus 16 equals 0. All right, let's see, is this factorable? So we got 4, 3 is 12. 3 times 8. No. Anything else? I don't think it's factorable. Check one more. So, yep. So, looks like we're going to have to do the quadratic formula. Oh, kick me out again. So I guess I was trying to tell me it's enough for the day, huh? All right, so 39 squared, 4 times 9 times 16. That's 2 times 9. I wonder if I missed a term or something. Just trying to make sure because the number's getting a little large. So the square is x plus 1, 3 minus x. That turns into 9, x plus 1, right? So it's 9x. 3, 9, 15, 15. Yeah, feel like I'm okay. All right. So that's 39 plus or minus 39 squared, 1521. 4 times 9 times 16. 576 all over 18. $39 plus or minus 945 all over 18. All right, now okay. Almost finished. I can break up that 945 into 9 times 105. Take the square root of 9, and that's 3. And I can reduce this by 3 in both cases. So that'll be 13 over 6 plus or minus square root of 105 over 6. All right. So those will be your two answers. So you might see one like this on your homework, but I'm pretty sure I didn't put one like this on the test. So, but either way, you should be able to, the concepts, you know, are still the same. You should be able to knock them out. So once again, try the stuff out, see if you get stuck on anything. And if you have any questions, you know, you always feel free to email me and I will email you back. So we're 3 minutes over time. I know I'm sitting back for one of your classmates, but outside of that, have a great weekend. Be safe, and I will see you on next class.
I asked the question about the test because I thought